In some of the sessions, we have discussed about the effluent treatment process or plant, that is ETP. Then we have discussed about the STP, that is sewage treatment plant. We also discussed about the CETP, that is common effluent treatment plant, and now it is a different task, that is sewage sludge treatment. So normally when the sludge is produced in the STP, that is sewage treatment plant, so that sludge can be treated in a different way and that can be converted into a wealth. So what exactly the treatment is, what is the procedures to be adopted for this sewage sludge? So we will discuss what exactly the sewage sludge treatment process. Organic wastewater solids that can be reused after stabilization process such as anaerobic digestion and composting is called as biosolids. So whatever the solid material is formed due to some of the process like anaerobic digestion or composting, that solid which is useful, that is organic waste or organic solids, that is also called as biosolids. So sometimes this sludge may contain some of the harmful components in the environment, and that should be avoided or that should be separated out from these biosolids. So this is the sludge which is showing in this picture. Sludge is mostly water with lesser amounts of solid materials removed from the liquid sewage. So in this sludge, the part is solids as well as liquid. So mostly the water is a liquid component. Then there are two types of sludge. One is primary sludge and second one is secondary sludge. Primary sludge includes settleable solids removed during the primary treatment in the primary clarifiers. So if the solid particles which can be settled out with the help of gravity as well as with the help of stirring technique, which can be done in the primary clarifiers in the STP plant, then that sludge is called as primary sludge. If the secondary sludge is there, it means the secondary clarifiers are required or bioreactors are required to settle down these types of sludge, then it is called as secondary sludge. So which can't be settled down in the primary treatment of the STP and which can be done in the secondary or the bioreactors, then it is called as secondary sludge. So focus of this sludge treatment is to reduce the weight of sludge and volume to reduce the disposal cost. Water removal is the primary means of weight and volume reduction, and there are different types of treatment available for this sewage sludge treatment techniques. That may be a air drying, that may be a composting or some other processes. So let us discuss one by one what exactly the processes are available in the market. So the first stage for this sewage sludge treatment process is thickening. Thickening means to remove the maximum moisture or the water from this sludge and then create a maximum solid contents. That solid contents or solidified part is called as sludge, and the equipment in which this activity is done is called as gravity thickener. So the first step in the sludge treatment process is thickening. Sludge from the primary or secondary clarifiers may be stirred to form a larger, more rapidly settling aggregates, and primary sludge may be thickened to about 8 to 10% solids and secondary sludge may be thickened to about 4% solids. So from this diagram you can understand this effluent, that is inlet. This effluent is sent to this part that is at the surface of this thickener, that is gravity thickener, and these parts can be rotated. So stirring process can be done with the help of this motor and shaft assembly, and with these types of blades this total effluent can be stirred, and with the help of gravity or gravitational force the solid particles can be separated out which can be called it as sludge, and the clean water is going to send for the next stage. So this is the first stage of the sewage sludge treatment process, that is called as thickening, and the equipment is called as gravity thickener. The second stage is dewatering. So we have to remove maximum water. Now in this case, we are going to remove this water with the help of squeezing process, with the help of centrifugal force, with the help of filtration technique, and with the help of evaporation process. So from this diagram, you can understand this is the effluent, and with the help of cloth, we can proceed this sewage, that is wet sewage, and this is going to compress with the help of this compressor or roller assembly. With the help of these different rollers, different size rollers, we can compress this sludge, and then even we can use a rotation technique as a centrifugal force source. We can use a filter, that is a mesh filter or a mechanical filter for the filtration technique, and we can use the sunlight as a natural source of heat for the evaporation purpose, and in this way we can use the dewatering technique, that is nothing but the removal of maximum of water contents from this sewage. So after the treatment of all these activities, that may be squeezing, gravity, centrifugation, filtration or evaporation, we can get near about a solid contents near about 50 to 75% of water. So these solid contents are removal in this second stage, that is dewatering technique, and then it is going to send to the next stage. So these side streams from this dewatering technique may be in terms of sludge, maybe in terms of liquid. If it is a liquid part, then it may require a further treatment, because in the liquid sewage, the nitrogen and phosphorus part is more. So we can use some of the techniques to recover the phosphorus from these liquid parts, and we can send these liquid parts for the digestion purpose. So in the digestion, so normally when we are talking about the sewage treatment plant, we can use UASB reactor, that is anaerobic sludge blanket reactor, where the digestion or decomposition is going on in the absence of oxygen. That is why it is called as anaerobic. So anaerobic process, sludge is there, we are treating this sludge, and there is a blanket, that is why it is called as anaerobic sludge blanket reactor. So in this USB reactor or in this digestion, the main output is the biogas, which contains near about 65% of methane, so which can be used as a fuel. That is one of the plus point in the digestion technique. So there are two types of digestion, one is anaerobic and second one is aerobic. So anaerobic digestion means the decompositions or the bacterial process in absence of oxygens. So there are two types of anaerobic digestion again, that is thermophilic digestion, which can be a technique operated at 55 degrees Celsius, that is fermentation activity at 55 degrees Celsius, and second one is mesophilic digestion. So this fermentation is at the temperature of 36 degrees Celsius. So the manure, food waste, biosolids or agricultural waste can be fed to the anaerobic digester, where the bacterial composition or bacterial process is going on in absence of oxygen. That may be at 55 or 36 degrees Celsius, depending on the type of bacteria present in that digester. That may be a thermophilic, that may be a mesophilic, and then after some days, these all these waste can be converted into biogas and digested. So this digested can be used as a fertilizer for the agriculture, and this biogas can be used to generate the electricity, to generate the heat by combustion of this biogas, or biogas can be utilized in blending of this CNG, and that can utilize as a fuel in the vehicles. This biogas can also be connected to the gas grid wherever possible. So this is the anaerobic digestion process. So that may be a mesophilic or that may be a thermophilic. So these are the MAD, that is mesophilic anaerobic digestion process, where hydrolysis, abiogenesis, acetogenesis and methanogenesis are the four stages where the MAD is proceed. And the duration for this MAD, that is mesophilic anaerobic digestion, is around minimum 12 days. And the main output of this mesophilic anaerobic digestion is methane, which can be acts as a biogas and it is a fuel. Then there is a second digestion type that is called as aerobic digestion. So aerobic, the name itself clearly mentioned that the bacterial process which is occurring in the presence of oxygen. Anaerobic is in absence of oxygen. Now aerobic is in the presence of oxygen. So under aerobic conditions, bacteria rapidly consume organic matter and convert it into the carbon dioxide. Once there is a lack of organic matter, bacteria die and are used as a food by other bacteria. So if the organic matter is present, it means the waste is present in that sewage. So that sewage waste or that organic matter is consumed by the bacteria and then it is going to convert into the carbon dioxide. If the organic matter is not present after some time, then obviously the bacteria is going to die and this bacteria is going to convert as a waste again, and that is the process which is called as endogenous respiration. So these solids reduction occurs in this phase, and because of this aerobic digestion occurs much faster than the anaerobic digestion. So the bacterial process is faster in this aerobic digestion as compared to the anaerobic, and the cost of these aerobic digestions are lower than the anaerobic digestion process. So from this diagram you can understand. So it is an open reactor and it is in the presence of air. So these diffuser pipes and diffuser ports are provided and cement concrete is utilized for the sturdy or rigid operation of this equipment, that is digester. So we have already discussed these operating costs, and the rate is in the aerobic digestion is more as compared to the anaerobic digestion. Now the recent technologies or the advances are utilizing the non-electric aerated filter systems that use the natural air currents for the aeration instead of the electrically operated machineries, because in the aerated or aerobic digestion systems we have to consume more and more electrical energy. So this is the latest change in the technology, that we can use the natural air currents for the aeration instead of electric aerated filter. So if it is done or if it is feasible, then we can reduce the cost of this aerobic digestion process. So this aerobic digestion can also be achieved by using diffuser systems or jet aerators to oxidize the sludge. Then fine bubble diffusers are also useful and cost efficient technology which can be useful in the aerobic digestion. Plugging is one of the main problem in these aerobic digestions. And then we can also use the coarse bubble diffusers. So fine bubble diffusers and coarse bubble diffusers are commonly used in the cost efficient diffusion methods and in the activated sludge tanks or in the flocculation stages. So these are the different technologies or diffusers which can be used in the aerobic digestion process. Then the next stage is composting. So Mixing sewage sludge with agricultural byproduct is called as composting. So the agricultural byproduct like sawdust, straw or wood chips are the examples of these agricultural byproducts which can be mixed with the sewage sludge, and if it is mixed then composting can be done. So in the presence of oxygen, bacteria digesting both the sewage sludge and the plant material which can generate the heat to kill the disease causing microorganisms. So in this composting process, the disease causing microorganisms are killed by the positive bacteria, and this positive bacteria is using this mixed sewage sludge and agricultural byproduct as a food. It means they are going to consume this sludge as well as this byproduct as a food, and after consuming this sludge and byproduct, they are going to generate a heat which is useful to kill the disease causing microorganisms and parasites. So maintenance of these aerobic conditions with 10 to 15% oxygen requires bulking agents allowing air to recirculate through the fine sludge solids, and the stuff materials like corn cobs, nutshells, shredded tree pruning waste or bark from the lumber or paper mills better separate sludge for ventilation than the softer leaves and lawn chippings. Then light biologically inert bulking agents like shredded tires may be used to provide structure where small soft plant material are the major source of the carbon. Uniform distribution of these pathogens killing temperatures may be aided by placing an insulating blanket of previously composted sludge over aerated composting piles. So in this composting process, we are going to kill the disease causing microorganism. We are consuming this sludge and agricultural byproduct with the help of microorganisms or positive bacteria. So initial moisture content in this composting is near about 50%, and then odors may be minimized with the help of aeration technique, that is with the help of air, and then liquid accumulating in the under drain ducting may be returned to the sewage treatment plants. So whatever the liquid is accumulated or retained in that composting process, that can be returned to the STP. So after composting, internal sufficient for pathogen reduction, composted piles may be screened to recover the undigested bulking agents for reuse. So after digestion or after composting, we can separate out the different size materials, composting material. The optimum initial carbon to nitrogen ratio of composting mixture is between 26 to 30 as to 1. The composting ratio of agricultural byproducts may be determined by the amount required to dilute concentration of toxic chemicals in the sludge to acceptable levels for the intended compost use. So this C/N ratio, that is 26-30 to 1, is again a key parameter wherefrom we can understand this compost is ready for use. And this is the last stage of this sewage sludge treatment process. Normally we are not adopting this stage, that is called as incineration. So incineration is nothing but the burning or combustion process. So in case if the sludge is not useful, it is not useful to convert into compost, it is not useful to treat or reuse or can be treated in the STP again, then and then only the last stage or the last option is incineration, which is not the routine case in India. But if it is the case, then this is the diagram where you can understand the how incineration process is going on. So in this diagram, this is the sludge feed. So with the help of this conveyor system, we can feed this sludge into the fluidized bed incinerator, where this sludge can be suspended in terms of particulate matter which can be easily burned with the help of fluidizing air fan and the ignition source assembly. So after incineration or combustion, the heat which can be carried out by these particles can be recovered with the help of water. So water is going to absorb the heat from these flue gases, and these flue gases and some solid particles are going for the next stage, that is in the electrostatic precipitator, where this ash can be separated out, and again the clean gas from this electrostatic precipitator can be sent to the acid gas scrubber, alkali gas scrubber, and then for the back filter, where if the acidic fumes are present in that sludge, then that can be absorbed in this column. If the alkaline substances are there, then that can be absorbed by this alkali gas scrubber. And if the particulate matter or SPM are present in that sludge or these gases, then that can be blocked by the back filter. And then only these clean gases can be sent to the chimney, which can be sent to the atmosphere by monitoring the uh, ppm or mg per liter, or the maximum permissible limits, which is given by the pollution control board. So this is the last point of this incineration technique, or this is the sewage treatment process last point. So these are the points related to this incineration itself, which is I have already discussed that it is a less common process, and a fuel value of sludge is depend whether it is dry, whether it is a wet solid, and what are the characteristics are present in that solids. So sometimes it is 980 calories per gram, that is the thermal unit value for this sludge, and sometimes it is 260 calories per gram. It means if you are going to burn 1 gram of this sludge, then 260 calories of heat can be generated. And here, with the help of 1 gram of this sludge burning, you can produce this 980 calories of heat. The limitation of this incineration technique is that it tends to maximize the heavy metal concentration in the remaining solid ash required disposal. So if the heavy metals are there after incineration, the ash is separated out. So if the ash is contained these types of contaminants, then that should be sent to the disposal. So all these things are again not the cost efficient technologies. So these require the further treatments, and that is why incineration is not going to adopt by the any type of countries or sewage treatment processes. Then drying beds is one of the technique where you can remove the maximum moisture with different techniques. So this is one of the technique. From this diagram you can understand what exactly the design of sludge drying bed is. So this is the sand, this is the sludge, and here it is open jointed pipe, and here it is a gravel. Different size gravels can be used, different size sands can be utilized, and with the help of this design we can de-water this sludge, means we can remove this water from this sludge. So percolation of water through these sands, through these pebbles, and this water can be easily removed. So the solid contents are more in this sludge. So this is the basic design of this sludge drying bed. So this is the simple and cheap method for drying the sewage sludge. Draining water must be captured. Drying beds are sometimes covered but usually left uncovered, and whatever the layers I have shown you, there may be a first layer of coarse gravel 15 to 20 centimeters thick, followed by a fine gravel that is of 10 centimeter thickness, and the third layer is sand that can be between 10 to 15 centimeters and serves as a filters. So depending on the flow rate, depending on the quantity, we can adopt the different types of drying beds. So this is one of the design of this drying bed. So this is the sludge, different types of sands and their sizes and their thickness, different layers, and here gravels can be set out, and in this way also you can separate out the water and you can dry the sewage. So this is the actual photograph of the mechanism or the plant where this drying of sewage can be done. So here under drains, gravels and sands can be utilized in this drying bed technology. So it is made from the open joint vitrified clay pipe or tiles of at least 10 centimeter diameter. Pipe should not be laid more than 6 meter apart from each other. Arrangement should be made to return the drain water to primary sedimentation tank. It is called as under drains. So these are the technical and dimensional specification, that 10 centimeter diameter and 6 meter apart from each other. Then gravels, we already discussed, different layers may be there. Layers up to 30 centimeters, that is graded gravel, minimum 15 centimeter above under drain. Then at the top 3 centimeter level layer of gravel is of 3 to 6 mm size, and then sand is effective when the size is between 0.5 to 0.75 mm, and uniformity coefficient not greater than 4 is used. The depth of this sand may vary from the 20 to 30 centimeter. So depending on the requirement, depending on the flow rate, depending on the quantity, we are going to design, we are going to utilize these different types of layers and different size of particles. So there are again other dimensions, like sludge drying beds are commonly 6 to 8 meter wide, 30 meter long. Then bed slope is 0.5% of length, should not exceed the 30 meter for single sludge application point. Then freeboard of at least 0.4 meter is used. Then sludge inlet, pipe minimum 20 centimeter diameter, and pipe should discharge sludge at minimum height of 0.3 meter above the sand bed, and splash plates should be provided at discharge points to spread the sludge uniformly over the bed. And then removal of sludge, that is dried sludge can be removed as a cake by shovel or forks when the moisture content is less than 70%. So the more than 70% of water is going to remove or eliminated from this sludge, and this dried sludge can be removed with the help of shovel or forks. When the moisture content is less than 40% of the sludge, it is suitable for grinding. After removal of the dried sludge, the sand bed is prepared by leveling for next cycle of the sludge applications. So these are the different dimensional details of this sludge drying bed. Thank you.